The next thing to look at is a pattern match condition. What is that? Well, it means that you compare something to a pattern in a string, which includes wildcard characters. What you're actually doing is you're looking for a value that matches a format where there can be more than one value within that format or represented by that format. As you can see, like condition says where something like or not like another condition. So that's the basic syntax. And let's go down to here. X not like, X like. There's escape sequences in there where you can escape certain things that you're searching for. An escape sequence is where you say, I don't want Oracle to interpret a character. For instance, in the last movie we looked at two quotes in a string to prevent interpretation of that quote where we said something tests. Oracle's not going to interpret that. You might be able to see this. In SQL Developer, this quote character is actually black. When you change and you put one in there, it turns to blue, which means it's not interpreted. If I do this, it should actually, I'm not quite sure what it's done there, but it's going to interpret this character. So if I have a string that includes this, for instance, it will interpret it as a backslash, which means something else. The only way to escape it is to tell it to ignore it, which has a very specific method in Oracle SQL where you actually use the word escape after the string and tell it to escape that character. In other words, ignore the character, interpret it literally. So it wants you to put that character in there. This happens to be a wildcard character for like pattern matching for a single character. I don't think I've actually ever used this. I generally always use the percentage sign. And let's get to some examples with like so we can understand what's going on. So first of all, we're using the ACK table here. So we're going to select everything from the ACK table. And let's take these separate examples. Let's go up to SQL Developer, wipe out this stuff here. Let's look at the ACK table. What's in the ACK table? All sorts of acts, from different types of sporting events to shows by people doing music concerts. I think this data is generally sorted because of the way I added it to the database. Mostly we can see WU down the bottom, we've got A up the top, and a number. Incidentally, in a string, a number sorts before all alphabetic characters. What this like means is that it's got any string with a lowercase a. Before that string you can have 0, 1 or many characters, and 0, 1 or many characters after it. So if I had an ACK name that was just this, it would find it. It would also find anything that had any kind of string before the A character and after. It would also find just A and then anything after, as well as anything and then A at the end. So it's finding anything with a lowercase a. So hit Control Enter. Grand National has an A, Arena Cross, Bob Dylan, so on and so forth. Lots of strings have A's in them. A is a very commonly used letter. Now let's go and look for capital A. In the case of capital A, it's going to be the first letter in a word, but a word is beginning with the vowel only, so we obviously get far fewer options here. And now let's go and look at any word that begins with an A, begins with an uppercase A, only Arena Cross. Let's go back to these ones, everything with an A in it. As you can see, this is actually not the beginning of a word, this is the beginning of the entire string. Arena Cross, go back to here. So we won't find, for instance, National Arena Cross because this is the second word. There are things you can do to find those, but that's a little complicated for now. This will find any string with a lowercase a at the end of the string. And obviously it finds A at the end lowercase, A at the end lowercase, A at the end. If we go back to this one here, we should find, for instance, Mamma Mia somewhere down here. Now let's go and look at this one. This example shows me acts that begin with an uppercase D. And we got Dave Attell, then it's Disney, Disney. Here's another interesting example. The word at the beginning of the string begins with uppercase D followed by I and any other letter. So obviously we are going to find the 2 Disney records. And it follows that we have another example that distinguishes between these 2 Disney records that we've just seen. Disney on Ice, 75 Years of Disney Magic. This one finds everything that says Disney on Ice at the beginning of the string. This one here has a single character after the word ice. And guess what it finds? Just the second record. Why? Because the first record actually ends and there's nothing after the letter E on the end of ice. So this doesn't exist. As you remember, this counts for 0, 1 or many characters. This counts for exactly 1. There is not exactly 1, not even a space after Disney on Ice. So in the second example, Disney on Ice doesn't appear, only the extended name. Here's yet another example. Select everything from the act table. Let's go back to there. Finds all the rows. 54 rows. If you know, I'm scrolling down, I'm looking on the left, it says 54. That's the ID number or the internal row number generated by SQL Developer when it pulls the rows. If I select this and I say everything, it actually is telling me to pattern match everything. Find all the rows. It's doing a full scan anyway. I could put lots of these in here. It wouldn't make any difference at all. Still got 54 rows. So let's count the act table rows that match anything. 54 rows. And the same applies to this example. 54 rows. That's the like comparison.